Hello there, and welcome to the Next Generation DDoS webinar sponsored by Kentik. Today we're going to be looking at the changing nature of DDoS threats and how big data analytics can help you achieve an optimal posture for defense and protection. Our presenter today is Jim Fry. He's Vice President of Product Management at Kentik. Prior to Kentik, Jim was Vice President of Research at the analyst firm Enterprise Management Associates. And before that, Jim spent time in executive roles at NetScat and Micromoves. So he brings a wealth of insight and experience to this topic and the topic of big data analytics. Now, note that there is a Q&A panel where you can enter questions, which we will get to at the end of the presentation. So now with that, I'll hand things over to you, Jim.
Thanks, Alex, and welcome everyone. Thanks for joining us. I think we have a very interesting and timely topic today. We're going to talk about DDoS detection. Alex said, welcome to this webinar about NextGen DDoS. Well, we're going to talk about the detection and how the sort of latest changes in the DDoS landscape are really presenting some interesting challenges, and it's making everyone rethink the way that they're going about their defenses. So just a quick preview of the agenda, what we're going to cover here today. I'm going to start with a little bit of a quick contextual landscape peek at what the challenges look like today. And then we'll talk about the equation for mounting a defense against DDoS and the combination of mitigation and detection that you have to bring together to do that. We're going to take some time and take you through a case example from our own experiences of Kentik customers to show you some examples of what an attack looks like and some of the challenges with really trying to get to the bottom of an attack. And then we're going to talk about how big data can get used to really give you an advantage in this regard. Then we'll do a quick intro at the very end, just a couple slides to how we're approaching this and what our solution is, and then open it up to Q&A. So again, any questions along the way, please log them in our questions panel. Okay, so first off, the DDoS landscape. Here's the obligatory portion of every security-related presentation that gets everyone scared. So I'm calling it clear and present danger, not because it's necessarily something you need to batten down the hatches on and worry about too much, but the reality is DDoS is a part of everyday life now. It's here, it's every day. People are experiencing it on a constant basis and on an increasing basis. So what I want to start with here is just sharing some industry data. We've been around as an operating company out of stealth only for about 7 months now, and we've been very active in helping people solve DDoS challenges. But there's a lot of others who've been watching this space closely for a couple of years. So I'd like to look at some of their results and some of the tracking they've done to give us some idea of the context of the challenge we're facing. So the first one that I'm going to show you is some numbers that come from a report from one of the DDoS mitigation cloud providers, Neustar, and they did some surveys and published. And by the way, all of the data I'm going to show you comes from last fall, and most of it is as of the end of Q3 2015. We haven't seen the reports come up yet and be published that go through the end of the year, but the trends I think are pretty valid, and I think we'll just see for the most part, most of the trends continue and things to get incrementally worse. Okay, with that said, so there's a bunch of data points here that come from sort of middle of the fall, last fall. So this one was interesting, I thought, and that Neustar in their survey found that fully 50% of the people they talked to had been undergoing DDoS attacks. And of those, the vast majority were getting hit repeatedly. Excuse me. Interestingly, also, they were looking at the sort of rates and how often these attacks were taking place. They were seeing at least 30% of folks being hit at least on a monthly basis. And then these attacks can range. They can range anywhere from a couple minutes to a couple hours, but according to Neustar's research, they were seeing a full 40% of attacks that were lasting in excess of 24 hours. So that's quite a long, extended period of time. Our own experience in Kentik is that we certainly have a number of customers that are undergoing regular attacks, really literally like on a daily and sometimes an hourly basis. So a frequency of 31% being attacked at least monthly seems like a relatively easy situation compared to what we've actually seen live in the wild. So the next thing I want to talk about briefly is the fact that this is a complex environment. There's lots of different types of DDoS attacks out there. They fall into a number of categories. Various different people divide and subdivide them in different ways. But essentially, you could think of them in a couple of different types. There's volumetric attacks, which are really designed to just overwhelm resources, network or server resources typically, with some type of network traffic or some type of traffic that servers have to process. Some examples shown here. Another type is what we call low and slow. Low and slow does not try to overwhelm with volume. It instead tries to tie up resources, typically on the server side, with processing and with doing things way more slowly than they should normally take, and making servers keep open these windows and keep context to these exchanges, and sucking up resources that way, and preventing actual real legitimate traffic from being serviced. And the last group is application layer type attacks. These tend to focus on specific protocols or application flaws. So you can see some of them are specific to HTTP. DNS amplification falls in this category, things like regex. So some of these type attacks actually could be described as more than one of these types. And that's the reality, is that there is, it's more complex than just making lists like this, but the takeaway is that there are many different types of attacks. There's sort of a continuous addition of new types of attacks. It's a changing landscape. Next thing I want to share, though, which is interesting, I think, is where do we focus and what do we worry about most? Akamai, in their State of the Internet report last fall, indicated that of all the attacks they were seeing, still 95% of them were focused on the infrastructure layers. And this means focused on exhausting network or server resources typically. And only not even 5% were the application layer DDoS type attacks. And of the types of infrastructure attacks, you can see there's really quite a mix. There's no dominant type. There's a lot of different types of attacks. UDP floods and fragments, NTP and SSDP, all of these above SYN floods, even DNS, all above or around 10% of the types of attacks that happened in Q3 last year. So the takeaway here again is you have to be prepared for a mix and a variety, because you're never sure exactly what type of attack is going to be coming your way. Next thing I want to share is a couple more numbers, this time from another cloud mitigation provider, VeriSign, who also does reports on trends. I think they had some interesting points to make about basically evidencing what we all know, which is that the size and the frequency continue to grow. So they had logged a 53% increase Q3 versus Q2 last year in the number of attacks, and a 27% increase in the average size. So the average size goes up and down, but generally tends to trend up. So in Q3 for VeriSign, they were seeing 7 gig as an average attack size. But interestingly, 1 in 5 attacks, or 20% of the attacks they logged, were over 10 gig. Now, certainly, DDoS attacks can be much larger than this. There have been well-documented examples of multi-hundred gigabit attacks, 200, 300, even approaching 400 gigabits. And it's really not going to be that long. The general consensus is it's not if, but when we start to see even terabit level attacks. So large attacks, growing attacks, once you start getting over 10 gig, that can get to a point where some organizations who are using 10 gig connectivity to the internet are going to be facing significant problems with network congestion and having their network pipes completely clogged by these kinds of activities. Let alone concern about the server, the network itself becomes a serious choke point if you start undertaking attacks of this size. So a couple more points on the landscape here. One of the things I think that gets talked about a lot, and one of the things we're going to talk a little bit more about today, is where do these attacks come from? And of course, there's the usual suspects, the BRIC countries, but it comes from other places too. There's commonly, as this example from Akamai shows, UK and US are common sources as well. So places that you think that might be relatively less likely to be a source Absolutely. You've got compromised systems everywhere in the world, and so it can come from everywhere. Although we do see a normal set of, sort of usual suspects that we like to keep an eye on, because the chances that traffic coming from them is illegitimate versus legitimate tends to be greater. And last piece I want to share, something that I think we found very interesting is this sort of ongoing continuous ramp towards more and more percentage of DDoS being reflection-based attacks. Now, reflection-based attacks are of particular concern and interest because this is what's driving the large high-end volume attacks. Use of reflection as an amplification technique. It's becoming more and more common. Akamai says here in Q3 2015, it was up to over a third of attacks, or around a third of attacks, and I would expect to see this number continue to grow. This is where attackers are starting to find a way to gain leverage and to increase the volumetric aspect of their attacks. Okay, so with that context in mind, let's talk a little bit about what we're going to do about mounting the defense. And as I mentioned earlier on, it's really a two-part equation for how to defend against DDoS. The first step is figuring out how to detect and recognize and verify that, yes, indeed, I have an attack underway. And then taking the next steps, which is to mitigate that attack and try to reduce the impact that it's having on you and your organization. So let's think about some of the requirements. And the requirements for these two pieces, these two sort of pillars of DDoS defense, of course, are a little different. On the detection side, you're looking for timely recognition. We'll use the term real time really within a few seconds to, sub-minute is really where people want to be with this. As we talked about earlier, some of these attacks last for hours or even days. So you want to understand and make sure that a change in traffic you're seeing is a DDoS attack as quickly as possible so that you can minimize the sort of long-term impact of that attack. But it's also not realistic to do this on too narrow of a time frame because changes in normal behavior, normal organic and acceptable behavior does vary and may initially appear to look like an unusual increase in activity. So you've got to verify it, and this is where the next point I make about no false positives. You want to be accurate in recognizing and making sure that what you're looking at is actually a DOS attack. You don't want false positives that cause you to clamp down on legitimate traffic. And you also, on the other hand, don't want false negatives. In other words, you don't want to miss things. And this is a constant ongoing challenge with detection systems, especially a lot of the legacy existing detection systems. Another thing you want flexibility in your detection technique because, as we'll talk about more today, there are a lot of different strategies you can use on the mitigation side. So the detection approach you take needs to be flexible enough to work with whichever mitigation strategies you're using now and or might choose to use in the future. Detection should support automation and integration with other systems, both for connecting into mitigation, but connecting to other systems as well. So having an ability to share data from the detection system easily is very important. And lastly, and very importantly, it has to be cost effective. So you can't throw your entire budget at just detection. DDoS is one of the things you're worried about in terms of your broader, scheme of operations concerns. It needs to fit in with the grand scheme of tooling and technology you're buying and deploying, both from a cost of acquisition as well as a cost of ongoing administration. So on the mitigation side, things you're looking for there are adaptability, again, automation. You want some different deployment options. A lot of folks that we talk to don't want to have their mitigation technology turned on all the time or inline all the time. They would prefer to have it out of band or have it be turned on when they are under attack, but not be inline and be a piece of the delivery path all the time. So flexibility in the way you choose to deploy mitigation can be pretty important. And again, just like the detection side, it's got to be cost effective. So you have to look at both what the potential losses are around downtime associated with DDoS. You have to look at the choices between whether or not you want to use one technique versus another. Say it's perhaps on-site scrubbing versus a cloud scrubbing service. They all have different price points, different cost points. and you have to build out your business plan to make sure you're selecting the choices that give you the best coverage for the right amount of cost. So when it comes to technology options now, after you've figured out what your constraints are for requirements, again, there's some slightly different aspects to consider between detection and mitigation. On the detection side, kind of two key choices. You need to, first of all, figure out what your source of data is going to be. And there's really two predominant sources for DDoS detection. One is watching the packets as they go by and doing stateful inspection. This is a technique that's actually used for embedded detection within most scrubbing appliances. Flow monitoring is what a lot of others use and is much more lightweight, much lower cost, and doesn't have to be in line all the time. You don't have to be constantly watching and accommodating the volume of traffic, whatever that might be. The other choice is on how you deploy it, platform-wise. There are appliances that you can deploy that do detection. There is downloadable software that you can buy and download and install on your own system to do this. There's a growing number of choices that are SaaS-based, and that happens to be the way Kentik approaches this challenge. On the mitigation side, there's a lot of choices. You can do direct signaling to your routers using a number of different techniques. You can use a cloud-type service. You can use scrubbing appliances. And in some cases, you might simply not take any action at all, which is something that, some might seem counterintuitive. But depending on the size and the duration of a particular type of attack, it may or may not be worth invoking mitigation. You may have sufficient capacity. It might be worth just hunkering down and waiting for it to pass. This is quite commonly the case with small sort of incremental attacks that one of our customers I was talking with just a couple of weeks ago, their assessment is that they get these regular small-scale attacks, and they believe it's actually attack toolkits being demonstrated. And in that case, basically, it's just it's a small amount. It certainly falls within the realm of their total capacity. They tend to be very short-lived. By the time they really construct or take any sort of mitigating actions, the attack is over. So as long as they recognize that it's one of these types of small attacks, they actually just ignore it. If it's a big attack, different story. Then they invoke mitigation and they take steps to try to address it. But don't forget that no action can be a viable choice. So let's look at these graphically in terms of kind of how they look in terms of flow of traffic. So starting with a very simplified view here, and I apologize, there's so many complexities and variations to this that we can't really do justice to them fully in the short time we have here today. But just to kind of give you a sense for what the different options look like. When you have detection will normally be put somewhere close to the internet connection point for your infrastructure, normally near an edge router, so that you can watch traffic that's coming to you from outside of your realm of control. You will have legitimate traffic, but when attack traffic starts to show up and starts to work its way through your systems, that's when you'll want to recognize that and start to choose some form of mitigation potentially. So one of the choices might be simply raise an alert and have an operator look at this, or run an automated script based on that alert and take an action to change the way that the edge router, that first router handles that data, and or the way that it's broadcast. So you can use BGP route to black hole, or use something like BGP flow spec. You can use an access control list at that point. Any of these types of things can be used to interrupt that flow. Unfortunately, some of these techniques will essentially accomplish the attacker's gains and complete their attack and take you offline. So if you can't do a good job of characterizing where the attack traffic is coming from and try to limit that specific traffic, you may choose instead to route all traffic to that end server to a black hole so that it stops damaging the other traffic you have going in your environment. So RTBH, route to black hole, is actually quite a common request that we hear about. Another choice would be if you've got scrubbers within your environment, you may have them deployed in line where they are always watching and always ready to invoke mitigation. A lot of folks like to put them, though, out of band. and then when they see a problem, request that the traffic be redirected through their scrubbing array or their scrubbers. The scrubber then takes care of cleaning out the attack traffic and passing along the legitimate traffic for processing. Similarly, when it comes to cloud mitigation, you can choose to have all of your traffic go through a cloud mitigation service, or there are a lot of folks that we talk with that prefer to have cloud mitigation on demand, meaning when they see an attack happening, then they want to route their traffic through the cloud mitigation service to have it cleaned up before it's passed along. So one of the things you see in common across all of these, there are a number of mitigation choices, but detection is a common thread. Detection is always there and has to be part of the story while you choose whichever approach you're going to take on the mitigation side. So the question is how am I going to choose a best way to do detection? And I want to start by giving an example. Now, the example I'm going to walk through here is a case example. It is a true, real experience had by one of our customers. Of course, we've changed the addresses that we're going to show you to protect their identity. But basically, I think it's important to sort of see what a DDoS attack looks like and see some of the complexity that you need to be ready to deal with from a detection perspective. So this happened to have been a forensic analysis. This was not a real-time analysis, but it's good for sort of demonstrating some of the complexities we're looking for. So we start at this point, and we're looking at a network that's carrying between 40 and 70 gig of traffic. Looks like fairly normal variations of things, but of course, within average 50, 60 gig of traffic, there could be any number of DDoS attacks of multi-gigabit scale, and you might not really know they're there. So what our system does, and what you will want your detection system to do, is to watch for certain patterns of activity. So in this example, we looked across this time range, and one of the common things we look for, just to look for potential problems, is to do a screening by source geo. In this case, our source geo trigger, when we apply that filter across that same time range, shows some interesting behaviors, some concerning behaviors. Sure enough, when we look at source from China, we see a couple of significant spikes, significant departures from baseline. Now, we don't know yet for sure that this is a legitimate traffic, but it's definitely worthy of study because it's popped up and jumped far away from the normal baseline of activity. So one of the first things we would do here is to see if this is, from maybe just a few addresses shipping some big files. Maybe it's legitimate for that reason. So we can do a quick pivot and say, let's look at the total traffic, on the second spike, and drill in and find out, first of all, what are we looking at? Now, it turns out it's a sort of a two-hump a pattern of activity. And if we look at it by the number of unique source IP addresses, we can tell pretty quickly that this does not look like a case where someone was moving a big file back and forth. Not when you have this change. This looks like now a large number of unique source IPs hitting against this particular device, or hitting against, in this particular stream of traffic. So that looks very suspect. That looks like it's now looking more like a DDoS attack. When we look a little deeper, and we then look and see where is all of this traffic going to, now we know we definitely have a case where we've got DDoS because all of that traffic is going at one IP address. So it's suddenly this huge spike in external addresses going to a single internal address. So we wouldn't want to just stop there. The big question now is, what is that comprised of? What type of attack is this? I know I've got a lot of traffic going from a bunch of IP addresses externally to one internally. So let's look at the actual. First let's pull back and say we found something from China, but who else is involved? Let's make sure we understand the full context. And when we remove the China-only filter and continue to focus on just this particular set of traffic going to that unique destination, now we see that there's a big mix of geographies that are involved. So yes, China is the largest of those, no doubt. But we also see traffic coming in the same sort of dual hump pattern from Russia, from Japan, from Taiwan, from Brazil, There's U.S. traffic in there as well. There's Spanish, Spain, so we've got a whole bunch of different source geos that are contributing to this. The next thing that we want to do, and this is what I was assuming was next, was to look at the protocols. Let's figure out now, we know we've got multi-geography, we've got multiple IP addresses hitting us. Which protocol is it hitting us on? So this is where we're going to start to move towards how we're going to mitigate this attack, or how we would mitigate this attack. In this case, when we look at the protocols, we can see it's almost entirely UDP. There's a little bit of ICMP in there, but it's pretty much all UDP. And if we look now one step further and say, okay, let's look at the destination ports. This is where it gets most interesting. We can see that the vast majority of the traffic coming in are UDP fragments going to port 0. But right behind that is UDP port 53. This is DNS. So this is a very typical sort of profile of a DNS amplification attack that's generating a huge volume of UDP fragments. And that sort of combination is quite common for DNS amplification. But the most interesting thing perhaps is take a look at what comes up next. Port 4444. Turns out that this is a Kerberos service port. Kerberos is an authentication protocol, and there is a well-known exploit by which a volumetric attack on Kerberos service ports, at least in Windows, can cause buffer overflows that opens an opportunity to inject malware like Trojans. So we very well are looking at a complex compound attack here that starts with DNS, that generates and throws off a huge amount of UDP to basically hide the fact that there's another exploit taking place here. So this is the kind of thing that we need to understand when we now want to invoke mitigation, because there's a couple of things going on, some things we're going to want to try to do. We might want to try to limit the amount of UDP traffic that we're taking in against those addresses. We definitely have to do something about the DNS traffic coming in, but most importantly, it does look like there's been an attempt to infiltrate and inject something into this server. So we're going to need to do some more work to make sure that we don't now have some sort of Trojan installed on this server. So kind of as a summary, the last step that you would do here is to step back and say, all right, if I'm going to take mitigation from a network perspective, where should I focus my filtering? Where should I focus any sort of blocking that I'm going to do for this port, for this protocol, for this address? And if you can look at groups of addresses that can then be used to pass along to your providers, pass along upstream, by doing a quick view of this in terms of the sort of /24s where most of the traffic was coming from. You can see there's a couple at the top there that were pushing far more packets per second than the others. Even just taking those out of the equation would be potentially very helpful in mitigating this problem. So what we've seen in this case example, we had, first of all, based on just watching, suspect geos, we found some spikes. Turned out to be DNS amplification, but it was hiding another exploit. And we then moved on and said, okay, let's find the details we need to advise the mitigation strategy. Now, how long do you think this would take? In a lot of systems, it could take you quite a bit of time to go through this kind of analysis. But actually, within the case example we did here, it only took us about 3 minutes. Now, that seems almost impossible. So how is this possible? How could you go back and forth and through like that so easily? And this is where it's time for us to talk about big data and the way big data can be a huge advantage for these kinds of things. It's our finding that the big data analytics that are part of the solution we have provide some really significant advantages for doing this kind of analysis. So talking about big data, first of all, let's step back and say, we need to put that in context with the decision around your detection tooling. So a couple questions to sort of cover first. When you're looking at your tooling, remember you have to make a couple of choices. I mentioned these earlier. You might want to look at sources that are packet-based, and this will be very commonly the detection technique that you will get embedded as part of whatever sort of scrubbing appliances you choose. You can do separate packet-based detection. But that packet-based detection, the big challenge there is really the fact that you have to make sure your detection sensors are not overwhelmed by the volume of flow that could be going through them. And that means you've got to size them to handle maximum capacity. That means that you are going to be spending a lot of money on appliances. So flow-based approaches, gathering flow records from the infrastructure devices that are there, either analyzed locally or in a SaaS backend, will tend to be far more cost-effective than pure packet-based approaches. Now, maybe the packet-based approach comes as part of the deal with your scrubber appliance. That still might make sense from a cost-effectiveness perspective. But if you're trying to set up an independent detection strategy, flow-based approach is probably going to be the more cost-effective choice. You know, the other choice is this is going to be integrated or is it going to be separate? So the key takeaway here is when you've got a separate detection system, that gives you maximum flexibility for figuring out how you're going to actually choose to take whatever mix of mitigation steps you're going to take. The other problem is that if you're relying on an integrated approach with your mitigation service or appliance, then you probably have to have that inline or online all the time. So it doesn't work if you want to do an on-demand scrubbing, whether it's on-prem or in cloud. You still have to have a separate detection approach. So some things to think about. And the third thing to think about, which we think is really growing importance, is what is the capability of that detection tool? Can it support all of the use cases you need? And that really comes down to the architecture for handling all of the data associated with detection. So does the solution have a true next-gen data architecture, or is it really constrained with some sort of legacy architecture? So when it comes to data architecture, let's talk about this a little bit more. We really think it comes down to one key question, and that is whether or not you're going to summarize the data that you're bringing into the system. Are you going to bring it in and pick out the metadata, set that aside, and keep that, or are you going to keep everything? That's the big question. There would seem to be some advantages to summarization. You know, rationale and says that, well, it'll require less storage. And maybe searches against history would be faster because I'm dealing with lighter weight data. The downside is you lose essential detail when you do this. If you haven't defined your data translation, if you want to go back and look at the details later, they're not there. And so really with the architectures and the technologies we have today, you have to seriously consider not summarizing the data that you're bringing into the system. You can't afford to lose the details. You can't afford not to be able to see exactly what happened when you're going to do your forensics. So that's where we bring big data into the equation and why big data begins to be a very important consideration of choice. And the reason big data is now the right time for and the right angle for this is that, first of all, the type of data that we are gathering for DDoS and for general network monitoring really is big data. It fits all the tests. You know, it really is high velocity, it's high variety, it's high volume. You know, we're seeing millions of flows per second on a regular basis, billions per day. The other key thing is that big data technologies have absolutely matured. Now, a lot of them were built for the batch mode offline world, but they've adopted, and they are now capable of handling real-time data sets. They're reliable and scalable, and they're high performance. This is the other big rub against a lot of the original big data architectures was that, yes, you can handle a lot of data, but it wasn't very fast. That's changed as well. So big data has moved forward to a point where, as an architectural construct, it's possible to get the same kind of performance you would get from other types of data architectures that can't handle the fact that you want to keep all of the data, not just summaries or metadata. So what are the big payoffs if you actually do this? You decide, okay, I'm gonna go with a big data approach. Why do it versus just a well-outfitted non-big data strategy that does large-scale summarization but can handle a lot of data? Well, it's really kind of comes down to a couple of those early requirements that we talked about. One is accuracy. And this is really key to that question of false positives versus false negatives. And it's really key to being able to understand when if you have an attack going on that you didn't anticipate or that you didn't predefine a filter for, you didn't predefine an alert for, how do you get to the bottom of it and make sure that you are able to accurately understand exactly what was going on? You know, a big question is around the false positives. You know, you need to be able to figure out rapidly, is this myself? Is it a friend? Or is it truly a foe? Is it truly, you know, someone who's attacking me? So accuracy is a huge element, and accuracy comes down to making sure you've got complete fidelity of data. The other really is flexibility. Big data platforms, when you have all of that data in hand, put you in a much better position for a number of things. One of them is being able to adapt to the constantly changing nature of the threat landscape. Being able to you know, realize that, hey, there's a new type of attack coming along. I don't want to wait for my vendor to build a new filter or to help me figure out how to predefine, you know, the way I'm going to watch for this. The data's all there. You can go characterize it, and you can go build your own alerting technique for that. It's also really important for extensibility. You know, big data, one of the definitions of a big data architecture is extensibility and the ability to add and enrich data sets with more detail. And finally, big data systems, for the most part, are built to make it very easy to get data back out of them and share that data with other systems. This is a shortcoming of a lot of other tools out there that do not have well-formed APIs and do not have an ability to gather and share data with other systems. So these are some of the reasons why this sort of big data strategy starts to make a lot of sense for DDoS detection. So a quick word here before we wrap up on what Kentik is doing about this and what our strategy is. We do use NetFlow as a source of our analyses. We use a big data approach. We deliver it via SaaS. And we are having great success applying this to the DDoS detection use case, and of course, many other use cases in parallel. So really quickly, the structure of our solution is all built around our big data engine. We call it Kentik, the Kentik data engine. It lives in the cloud primarily and is offered as SaaS, although we do offer on-prem deployments in certain situations. We harvest data from the network, and we make the results, the analyses that we run, we make the results available via web, via automated alerting for DDoS or operational scenarios that you want to look for, and through open APIs as well. Behind the scenes, you know, behind our Kentik Detect service is a true big data engine. So the Kentik data engine is clustered, it's multi-tenant, it's designed for massive scalable data intake and ingest, but also optimized for extreme rapid response when any sort of question is being asked against it, any sort of query is being run. So most of our queries run in a few seconds time range against, you know, whatever large volumes of data you want to pull against it. We've designed it to handle that. The result of what this looks like, and this is not DDoS specific, but just in general, is a way to navigate large volumes of data that are very complex, but being able to pivot, to add filters, to nest filters, to remove them, to turn and navigate in what we call down to infinite granularity, all the way down to the original raw flow records. So we keep all of our flow records so you're not constrained whatsoever in your data exploration. And it's designed to be quick, fast, intuitive. It's really designed with the operator in mind so that operators can get through their analyses as quickly as possible and look like and go through the sort of sequence of steps that I talked about in our case example, literally in a matter of a couple minutes. We also, of course, have dashboards that can roll up to show you aggregate views and you know, show multiple metrics side by side. This example is of some security-related view that was built up, but you can build whatever sort of combination of metrics you'd like to watch. All of it designed to be watching and harvesting and analyzing NetFlow as it comes in real time and presenting results to you within minutes. So, key takeaways. back to NextGen DDoS detection. What should you expect? What should you look for? You really do want true live monitoring. You want something that is keeping on top of the data as it comes in so it can tell you within seconds whether or not you are likely under a DDoS attack. It needs to be operating on a complete full fidelity data set so that you are not constrained in any way from digging into and doing forensic analysis and deciding and verifying whether or not a problem that's been identified or a potential attack that's been identified is indeed a threat versus normal activity. You need to have a solution that's going to put you in a position to mix and match whatever kinds of combinations of mitigation approaches you want to take. Not just today, but also to keep your options open down the road. And lastly, it really needs to be in position to help you with automation and being ready to respond, in an automated, quick fashion to as many scenarios as you can. So with that, thanks very much for your attention. I would love to entertain any questions that have come up. Alex, have you had any questions then?
Yeah, okay. So Jim, thanks very much. We have a few questions. I'll pick one that is kind of maybe a trend question. The question is the trend going to tip to where volumetric attacks become a minority and slow and low or application attacks become the majority?
So that's a really good question. I don't think we've seen an indication yet that application reach majority status. We'll keep watching reports as they come out from some of the large-scale service providers. They'd love to tell us all about that. But, given the numbers we had earlier that I showed you from the Akamai report, where 95% are still infrastructure focused. Now, that includes some low and slow, but most of it's volumetric. So I would say volumetric is still going to maintain, the majority status for quite some time. We'll have to watch that carefully, right, of course.
And isn't it the case, just as a side point, it seems like one of the things that's fueling a lot of the volumetric, the growth in volumetric attacks, particularly reflection-based amplification, is the fact that there's so many more IP-enabled devices. Kind of like the Internet of Things is creating this bonanza for more reflection because of all these devices to reflect off attacks off of.
That is a very concerning situation for sure. But whenever we hear about IoT platforms that can be exploited and turned into bots and or be used for reflection, yeah. I mean, this is part of the concern and the reason why I shared that bit of intelligence around the growth in the percentage of attacks being reflection type attacks. It means that the volumes we're going to be seeing, the size of attacks will continue to grow and grow fast. And when they grow fast like that, it means that it's going to change your strategy around the steps you need to take that are more proactive in nature around avoiding total clogging of your network links.
Okay, great. A more specific technical question came up regarding flow spec specifically, which is how common is flow spec today? Is anyone really using it?
That's a great question. We have a lot of conversations with folks that are very interested in it. Flow spec has been an emerging technique for many years now. It certainly conceptually sounds very attractive. A lot of people want to be able to use certain aspects of flow spec. We've not actually seen much of it in the really live in production yet, but a lot of conversations around it, a lot of hope for it. I'll say right now, besides BGP flow spec, actually OpenFlow on the SDN side is getting similar levels of interest within certain organizations that are trying to look towards SDN architectures. So again, I think we'll see this more on a case-by-case basis where people are starting to actually use this and try it out, but it's not in the mainstream yet.
Right. Yeah, I remember seeing a kind of a lab example from, I think it might have been Brocade, about using OpenFlow for DDoS mitigation. But I think that's an interesting one. still seems more in the lab than it is in production. Okay, so the next question is, most DDoS protection products run on 8-core CPUs. Okay, so that sounds like, DDoS appliances, maybe integrated ones. Isn't that enough for attack detection? If that's all you need, isn't that good enough?
Yeah, so interesting. I would draw the same conclusion. That's talking about an appliance. So an 8-core CPU is a lot of processing horsepower. That's great. That's going to get you pretty far, and it might be all you need. But part of the problem is not just the processing horsepower; it's the volume of data. So an 8-core CPU maybe, if it's in an appliance that's doing both mitigation and detection, or detection and mitigation, you're going to have to that box is going to be processing data. It's going to be using that same set of cores to actually do filtering and mitigation. So you're not going to get all 8 cores dedicated to detection. So it may be fine in smaller settings, but it may also not be enough, especially when you need to go back and ask that platform to start doing, large-scale data mining and data analytics, and vast amounts of historical data to do forensics. It may not be enough. So it depends on what you're trying to do with it and what your expectations are. But I would say just the fact that you've got an 8-core CPU does not mean you have a next-gen solution. It means that there's more aspects to it. You have to consider the total volume of data, both coming through currently as well as what you want to be able to look at forensically.
Yeah, and I guess some of the points you also made about the architectures of products being oriented towards openness and being able to share data with other systems, being very API friendly, et cetera, also tends to a lot of products that are built around a single CPU model tend to be more closed in that sense. Okay, let's see here. I think that was there was one more question actually come in, a new question. You mentioned that in terms of ways to handle an attack, that no action is a legitimate choice. And so I guess the question is, why or when is that a good choice?
Well, as I mentioned, the example, well, it's two parts. It's kind of interesting. So some folks, first of all, just don't have a good handle on what mitigation technique to use or what their options are really, and don't really have a good choice. But the case where no action is appropriate would be the example I gave from one of our customers who gets hit on a regular basis with what clearly, small attacks that fit known attack profiles, but aren't of large enough volume to cause them to really exhaust any resources, that don't interfere with the quality of experience that their legitimate customers are having, and oftentimes are not really true full-on attacks, but it look like they're just little test attacks. So sometimes they're so short-lived, they're only a few minutes. And so by the time you are able to, verify that this is not a false positive, there's little to be done from a mitigation perspective. You just allow those to pass by. And in fact, that's kind of the way that these folks told me about their approach to this, which is they see the attack starting, because within our system, they see it within, really, frankly, a matter of seconds. Depending on the pattern that it's following, if it looks like it's going to be one of these small sort of test trial attacks, then they'll just let it go by. But they watch closely to see if it's going to be more than that. So the big thing they're trying to do is coordinate the operations team and make sure the operations team is in agreement of, okay, what type of activity is this? Is it legitimate traffic activity? Is it an attack? And if it's an attack, is it one that we worry about or care about or not? And just even being able to quickly characterize and answer those two questions and then spread that information around the operations team has been huge from, from a sanity perspective for them, from a consistency of operations perspective. Because before they were using our system to do this characterization, anytime there was a blip, whatever time of the day or night, a couple of the lead engineers would get called or would get texted or paged, and would have to figure out what's going on because everyone had their hair on fire. But now that they've recognized that there's a couple of different types of scenarios for them to deal with, and they've been able to build that into the alerting that they use within our system, it's made the whole process much faster, much more automated, much simpler to communicate amongst the teams and to decide what's of concern and what's not.
That's one of the things that I think is interesting and kind of fascinating and sort of horrifying. That one of the points you bring out is that there are these sort of free trial attacks. That the nature of the threat landscape is highly commercialized, in a sense. That there are lots of, in a sense, commercial services where you can go and say, I want to launch a DDoS attack, and it's competitive enough marketplace where they offer free trials. So I think that's right, kind of it's an interesting way to think about the threat landscape. Is that it is a rapidly evolving marketplace for attacks, rather than some amorphous dark cloud, and that's
right.
That's an interesting, helpful way to think about it, I think.
Right. Yeah. One more question that came in.
Yeah.
Yep.
This question is
IP.
Go ahead.
Okay. Is IPv6 DDoS attack common? I don't have an answer for that. There are IPv6 DDoS attacks. There are some reasons why IPv6 actually is going to make some current IPv4 DDoS attack scenarios obsolete, which will be a good thing. But the challenge is that there's just not enough IPv6 out there to be as interesting to those two attackers versus IPv4. But something worth looking at, and we'll have to do a little research on that and what we're seeing from our perspective, and hopefully we can present that in a future webinar.
All right. Well, I think that's it in terms of questions. Again, I want to thank everyone for attending, and we'll be, as we finish this up, this webinar will be posted as an on-demand webinar. So we'll be sending out a link to everyone who registered, so that's something that you can go back to or share with colleagues. And of course, just want to invite anyone who wants to learn more about Kentik to let us know. Come visit our website, sign up for a demo, or sign up for a free trial, which is, you can hit that button on our website and actually start a free trial directly from there. So again, thanks very much and have a great day.